Okay, we're starting to make good progress. In my last video, I built out an OpenSense server, which will be used primarily for DNS. And this time I'll create something that I like to call a platform server, which will be used for shared services. To get started, let's take a look at the hardware. For this server, I'll use something a little more substantial. I'll go with a B-Link server with an AMD CPU that contains 8 cores, 16 threads, and at least 32 gigabytes of RAM. The hard drive will be a 500 gigabyte NVMe, and finally I'll be connecting it to my network using an Ethernet cable and a switch. Alright, so what is this server for? You see, for my applications, I'll need some shared services. Things like single sign-on, a container registry, secret management, and so on. So if you look at the architectural diagram, you might be wondering, what's the point of a separate server? I mean, why not just put the shared services in the Proxmox cluster? And the short answer is you could. But the reason I'm building out this cloud is for learning and experimentation. And separating out my shared services allows me to swap out my Proxmox cluster without losing things like single sign-on or my Docker images. Okay, it's time to build this out. For this video, I'll assume you already know how to install a Linux operating system, like Ubuntu. I'll also assume that you have a working knowledge of Kubernetes and its subsystems. Things like load balancers, Ingress, storage classes, and using Helm to install apps. As always, I'll have the full instructions in my GitHub page, linked in the description below. I've already installed Ubuntu, and this server will have an IP address of 192.168.3.3. Next, I want to install a lightweight version of Kubernetes called K3s. It's easy to install using this curl command. Once K3s is installed, I'll copy the kube config to my home directory. Just a side note, the kube config is the file used to connect to Kubernetes. It contains the URL for the cluster, along with the user and authentication information. With Kubernetes set up, I'll install a few tools. First, I'll install Helm, which is kind of like a package manager for Kubernetes. Since I'm using Ubuntu, I'll install it using the snap command. The last tool I'll install is K3s. Now, this is completely optional, but K3s makes visualizing and managing Kubernetes really easy. It kind of reminds me of the top command in Unix. To install it, I'll use another snap command, then create a symbolic link to the binary. Alright, I have Kubernetes installed, but now I need to add a few subsystems before it'll be useful. Now, Kubernetes is a huge topic, but at a high level, it manages containers like Docker. The containers run inside an abstraction called a pod, and the pod has a lifecycle. Where we run into a problem is when the pod terminates. You see, the containers running inside the pod are essentially stateless. Normally this is okay, but what if the pod is running a database? When the pod terminates, you would lose all your data. To solve this problem, we need a way to persist the data. One option is called Ceph, and I'll be using Ceph for my Proxmox cluster. Ceph is great, but it's really designed for installations where you have multiple servers to distribute the storage. Since my shared services run on just a single server, I'm going to use a lightweight solution called Longhorn. Longhorn will give me access to something called a StorageClass that will allow me to persist my data. This way, when the pod is terminated, the data won't go away. Installing Longhorn is really easy. Just run this kubectl command. We can then make sure that a storage class was created, and you can see the new storage class here. There is one minor problem. It looks like we have 2 default storage classes. To fix this, I'll run this kubectl patch command. Now if I view the storage classes again, you'll see that Longhorn is the default. Now we have another issue. My application is running on Proxmox will need access to the shared services cluster. And that brings up an interesting point about Kubernetes. In terms of external access, it runs in kind of a sandbox. The only way to gain access to the Kubernetes cluster is using something called a node port. And unfortunately, using a node port directly isn't very practical. They only run on TCP ports above 30,000. What we want is to access the Kubernetes cluster using port 443, which is the HTTPS port. To do that, we have 2 options. The first option is called a load balancer, And typically a load balancer is a separate server running outside of Kubernetes. Behind the scenes, it's wired up using node ports, but that part is usually abstracted away, so you don't have to worry about it. For my server, I'll use a load balancer called MetalLB. It's a little bit unusual in that the load balancer actually lives inside of the Kubernetes cluster. MetalLB is a layer 4 load balancer, which means it operates at the TCP layer in the OSI model, but it uses layer 2 ARP broadcast to draw in the traffic. To install MetalLB, I'll use this Helm command, then wait for everything to come online. And I'll also create a pool of addresses that MetalLB can use when allocating Kubernetes load balancers. And finally, I'll create that layer 2 listener that I mentioned earlier using a kubectl command. A load balancer works great, but it operates using an IP address and a port. So what if I want to access multiple services? I would need to create a lot of load balancers. And one way around this is to use domain names with URLs instead of IP addresses. To do this, I need to add another subsystem called an Ingress controller. The reason we need an Ingress controller is that URLs operate at layer 7 of the OSI model, whereas our load balancer only operates at layer 4 with IP addresses and ports. The solution I'll use for this is called Ingress Nginx. To install it, I'll use this Helm command. Once it's installed, I'll need to make sure an IP address was allocated using MetalLB. To do that, I'll run this kubectl command. And here you can see the IP address that MetalLB allocated for the ingress. Now all we have to do is set up DNS to point to the IP address. For example, we could assign the domain name vault.heavymetalcloud.lan to point to the IP address on MetalLB, which is 192.168.3.20. Okay, my shared services server is ready to go. In the next few videos, I'll start to install the shared services, starting with the Docker registry. Thanks for stopping by, and I'll see you in the next video.